Today in class we learned about reflections and translations. So we're going to draw reflected images on a coordinate plane, we're going to recognize lines of symmetry, and then we'll also draw translated images using a coordinate plane. So a transformation, first of all, is when you map an initial figure, we call that the preimage, onto a final figure called the image. So what we start with is the preimage, what we end with is the image. An isometry is an image that is congruent to the preimage. A reflection is a transformation that flips a figure. So you can see here we have the shape and it's flipped over. That's a reflection. A line of symmetry is a line that the preimage is reflected into to obtain the image. So I could draw the line of reflection like this, and you can see that our preimage here flips over and or flips over that line of reflection to obtain the image there. This asks you first to reflect the image in each of the following. The first thing I'm going to ask you to do is take this image and reflect it in the x-axis. We have to remember that the x-axis is our horizontal, so we're going to fold over it. If I label these vertices A, B, and C, then I will first want to look at A. It really doesn't matter which one you flip first, but remember that this is our line, so we're going to say how far is A from that line. It is 1, so we're going to go 1 in the other direction, and it will give you this point here. Call it A prime. So that is 1 unit away from the x-axis. Then we're going to look at B. B has a distance of 3, so we're going to go 3 in the other direction on the other side of the x-axis, which will put us up here. And C is also 3, so we're going to go 3 on the other side of the axis, which will put us here. So when we draw this, this is our image. A prime is located at -1, -1. B prime is located at -2, 3, and C prime is located at 2, 3. We did look at, in class today, we said, where is C located? C was at 2, -3, and we said, what happens between these 2 points? Because if we can make a general rule for this. If you're reflecting into the x-axis, then if your initial points are x, y, then the new points will change. And how do they change? It looks like the y value changes. So your x stays the same, but the y then is a -y. It changes the sign on the y. Oh, I think I put C prime there. That's just supposed to be C. So again, if we can make a formal rule, then we can use that every time, or you can just go ahead and flip each point individually. B asks us to reflect into a line. The line is y equals 2, so, or -2, so we have to decide where that is. It's right here. And we're going to fold over this, so we're going to take each point. I'm going to label them A, B, and C again. And we're going to say, how far is A from this line? You can see it's only 1, so we're going to go 1 on the other side to get our A prime. C is also 1, so I'm going to go 1 away from the line to get my C prime. And B is 5 away, and I'm off my graph. 1, 2, 3, 4. About right here would be our B prime. And there our triangle is. We can go ahead and write the ordered pairs for those values. For A prime, it's -1, -3. B prime is 0, and let's see, 1, 2, 3, 4, 5, 6, 7. And C prime is over 3, down 3. Now you could probably come up with a rule that you could write there, but I'm not going to. It would probably require more work than just actually flipping it and writing the coordinates for the ordered pairs. Okay, this one asks you, this one's a little bit harder for kids to see. It asks you to reflect in the line y equals x, and the first thing you have to decide is how do you actually graph this line. The slope is 1 over 1, its intercept is at 0, so we get a line like such. And I tell kids sometimes it's easier to see this reflection if you turn your paper sideways. We can see that, or it's easier sometimes to see that reflection if it's sideways. So what I'm going to do is I'm going to talk a little bit about reflection. A reflection, actually, if you were to find the distance from a point to a line, it would have to be such that it is perpendicular. So it would have to form a right angle. And then the distance from the point to the line would have to be exactly the same. So we can eyeball that and see that our point is probably going to land about there at A prime. And if I look at A is 1, 2, 3, 4, 5, back 5 up 1. My A prime is over 1 down negative 5. Now, if we can make a standard rule for this, then it will be, maybe it'll be easier to use. Otherwise, you're going to have to reflect each point. So this says if we have x, y, we reflect it into the y equals x line, or the line of y equals x, then we can see here that our coordinates just switch. Okay, so if I look at B, B is located at back 1, up 1. So B prime would be up 1, down 1, or sorry, over 1, down 1. And now if we were to connect those two, we should see that it's perpendicular, and the distance from B to the line and from the line to B prime would be exactly the same. Okay, C prime. Then if C is over 4 up 5, or sorry, back 4 up 5, then C prime would be 5, negative 4. And here's our triangle. And again, it's a lot easier to see this. If you look at it sideways, you can see that it's a reflection. Also, it's a lot easier when the value doesn't overlap the line, or the image does not overlap the line. If that happens, it's a little harder to see the reflection. On example 2, it says identify the number of lines of symmetry for each shape. So we're going to look at the first one. If we can draw a line so that it mirrors itself right here, well, it's not very straight. This pretty much cuts our image in half, and we can fold it over. Or here's another place where we could fold it over, and your image would still match on both sides. So we're going to say that this has 2 lines of symmetry. For our next shape, it is a regular pentagon, so that means all the sides are the same and all the angles are the same. So in that case, we get 1 right there, and you also get 1 here, you get 1 here, and you can see that we get 1 from each vertex. It's probably harder to see the more I draw there. So in this case, we get 5 lines of symmetry. For our third shape, there is no line that we can actually draw so that it reflects itself. And then on the last one, what I did earlier, I talked about if you can draw a circle around the object, then you can count how many times that circle, or the object, touches the circle. Here we can see that it touches the circle 8 times, so you will actually get 8 lines of symmetry. Now, for this to work, all of these lengths, if you notice, had to be the same. We could have done the same thing with our regular pentagon here. If we drew a circle around it, or we were to draw one, then we would see that the pentagon would touch our circle 5 times. Okay, it does not work with the rectangle because the rectangle doesn't have equal lengths. A translation is a transformation that moves all points on a figure in the same distance and the same direction. So I have a shape here. It now becomes that new shape, and we can see that it moves over and up. So that is one kind of a translation. A composition is a transformation made up of more than one transformation. So today we're actually going to do a translation followed by a reflection. So that's the composition that we will be doing. So here on example 3, we've done several of these preparing for your benchmark. So I'm not going to spend a whole lot of time, but you're going to apply the translation rule. So if I have A, B, and C here, this says each point we're going to move back 5 and up 2. So I just did A prime here. I'm going to do C, back 5 and up 2, and B, back 5, up 2, and there's your B prime. And here's our shape. I think it's a lot easier to see that these two shapes are exactly the same. So because they're exactly the same, we say that they are in isometry. And then we can identify those points. A prime is back 4, up 5. B prime is back 1, up 1. And C prime is back 5, up 1. Now, you could have done this without graphing by actually finding the value or the coordinates of A and putting them into the translation rule, but here where it actually asks you to graph, it's probably just as fast to graph. Okay, our last example, it wants us to actually do the composition. We're going to use the translation rule, and then we're going to reflect into the x-axis. So I'm going to start first by doing the translation rule. I'm going to move each point forward 4 and down 3. So I'm going to call this A, and that puts A prime right here. B, we're going to move forward 4 and down 3 for B prime. And C, forward 4, down 3. Alright, I need to go forward one more. 1, 2, 3, 4. And that gives me this image here. But we're not finished. It says following that you need to do a reflection. So we're going to reflect in the x-axis. The good thing is that if A is on the line and we try to reflect it, it doesn't move. So A double prime will be the exact same as A prime at 0, 0. B prime, now again we're looking at this line right here. How far is B prime from the line? It's 4 from the line. So we're going to go 4 on the other side of the axis. And that puts us at -1, 4. And C prime, again, we're going to look at how far is it from the line. It's 4, so we're going to go 4 on the other side to get C double prime. And this is over 3, up 4. And this is the image that we wanted to end with. Okay, hopefully that will help you with your assignments 10-1, reflections and translations. Good luck.